Now we're ready to take a look at a very important theorem. It is called the Factor Theorem. First, let's recall exactly what a factor is. You may think that it has changed meaning throughout your mathematical career, but truly it has not. First way that you learned the term factor was that it was two things we could multiply together to get another number. We talked about the factors of 81. It could be 9 times 9, 27 times 3. Anything I could multiply there, that became a factor. Then we grew up a little bit and they defined it instead as numbers that divide another number, and by dividing another number we mean with a remainder of 0. So since 81 divided by 3 was 27, 3 and 27 get to be factors. So see, it still had the same meaning. We were just looking at it from a different angle. Then when you get to Algebra 1, you get to look at it as not only numbers, but also expressions that divide other numbers or expressions with a remainder of 0. So if we looked at 2x plus 6, we said that that could be factored into 2 onto x plus 3, where 2 and x plus 3 are now my factors. So they don't have to be just numbers. They can also be expressions, or in the case that we're interested in right now, those expressions can be polynomials. So this is the statement of our factor theorem in algebra. It says if f of x is a polynomial, then if f of c is 0, then x minus c is a factor of f of x. And on the flip side of that coin, if x minus c is a factor of f, then f of c is 0. Now don't let that confuse you. Let's look at a very simple function, one that I know you know how to factor. That is x squared minus x minus 2. If I do a synthetic division and I try a 2, then 2 times 1 is 2, and I add. 2 times 1 is 2, and I add, and I get 0. So here's what this first one is saying. If f of 2 is 0, then x minus 2 is a factor of f of x. And of course you know that because if you factored that, it was x minus 2 and x plus 1. So if I get a 0, I put x minus my value c, and that's going to be one of my factors. But it's also going to take it in reverse. Because I knew that x minus 2 was a factor of f, I knew if I would put a 2 in the box, I would get a 0 for the remainder. It works in both directions. So here's an example of where I want to use the factor theorem. If I gave you this equation, most of you would immediately start trying to factor by grouping. Yes, you could factor out an x squared, but you can't make a 15x plus 14 out of this. If I regrouped, I could factor out a 3x, but that would leave a 5x squared. And here I could factor out a 2 and it'd leave a 7x squared. Factoring by grouping is not going to work in this case. So if I don't have another method to go about trying to find those zeros, then I don't know how to solve. So this is the method, and today we're going to be given the -1. Over the next few days, we're going to figure out how to find the -1. But for right now, take it. It's a gift. If I know that -1 is a 0, that means when I do a synthetic division with -1 in the box, I should get a remainder of 0. So I set up my coefficients in my box, and I bring down my lead coefficient, and I start my synthetic division. -1 times 15 is -15. 14 minus 15 is negative 1. Negative 1 times negative 1 is positive 1. And add, that'd be negative 2. Negative 1 times negative 2 is positive 2. And lo and behold, when I add, I do get a remainder of 0. So what this tells me is that I have f of x equals that, and that equals 0. So what I have is x minus negative 1, which I'm going to change over to x plus 1, times 15, 1 degree less, so instead of a cube I want a square, 15x squared minus x minus 2 equals 0. Now I'm down to a quadratic, and we've gotten pretty good at quadratics by this point. So I want to factor 15x squared plus 2. So 15 times 2 is 30. I need factors of 30 that give me a difference of 1. I think that's 5 and 6. I can easily make a 5 out of the 15x squared. That's going to be 5 times 3. To make a 6, I also need to say 2 times 3. And that's going to leave him to be the 1. The biggest product needs to be negative, so that means the 6 needs to be negative. And the 5 needs to be positive. Now that I've factored it, I've got 3 factors multiplied together to give me 0. So one of those factors must be 0. Either x plus 1 is 0, and guess what? You just found out again that that's negative 1, which we kind of already knew. 3x plus 1 may be 0. So 3x may be negative 1. And x then would be negative 1/3. And 5x minus 2 may also be the one that was 0. So 5x would equal 2. And x would be 2/5. So I have found all 3 answers to my cubic equation. Negative 1, negative 1/3, and 2/5. So that is why I want the factor theorem. It is going to save me a great deal of time.